Uh, All right. Hello, everyone, and thank you for joining me today. My name is Tushar Sonawane, and I'm a software development engineer at Amazon Pharmacy. Today, I'm really excited to talk about a subject that has defined my career journey. That's building scalable, innovative, and AI-powered enterprise solutions in the health tech. In this session, I'll talk about securing cloud-native health tech and how we as engineers design solutions that are not only technologically advanced, but at the same time secure, flexible, reliable, and impactful in helping improve the patient care experiences. So, before I go into my background, let me set the stage for what we'll cover in this opening section. First, I'll start by providing the context of health tech, why this industry is uniquely complex and at the same time uniquely ready for transformation. And then I'll share about a bit of my background at Amazon Pharmacy, where I was part of the organization before its launch. And then we'll discuss why this health tech industry is different than normal software industries and what are the complexities involved. And finally, we'll discuss some of the lessons that you will learn from today's session. So with that, about my background, I've spent the last 8 years in the tech industry, with the last 6.5 at Amazon Pharmacy, where I was part of the organization before its launch. At Pharmacy, I had this unique opportunity to work on systems from the ground up, systems that had to scale immediately, meet strict compliance requirements, and at the same time, deliver seamless experience for our patients. So I have led various projects during my tenure at Pharmacy, dealing with everything from architecture to performance at scale, from integrations to security controls, all around patient data. And I work with different varieties of teams like the compliance teams, the product, the legal, all in which have given me a well-rounded view of how things work in this health tech domain. Besides my work, I also mentored engineers, spoken on various panel discussions, and judged various innovation programs related to health tech, which has given me the front row seat to the opportunities and challenges in this health tech domain. Now, let's discuss why this industry is uniquely complex. So, to start with, building software in health tech is very different from building software in other industries. The complexity is not just technical, it's deeply human. So we aren't just building software that processes data or optimizes revenue. This has real world consequences on patients' care, their medication adherence, and even small mistakes can lead to life-threatening mistakes. So let's take an example. For example, let's say e-commerce. An error in their website could mean, worst case, your package may deliver late. But any error in the health tech domain could really impact patients' trust, their safety, medication adherence, and can even lead to mistakes on their end that can cause problems down the road for them. And second, we deal with HIPAA, which is Health Insurance Portability and Accountability Act, and we have GDPR and PHI. We need to follow all these regulations. So any architecture decisions that we make, they need to pass through all of these regulations and filters that are set in health tech. And then we also have system fragmentation. And that's a unique challenge as well, because most of these healthcare systems, they are all built on old legacy infrastructure, which aren't really meant to work together. So if you want to integrate anything or build upon it, it becomes a major challenge. And as we know, AI is already overpowering and is been recognized widely. But in healthcare, its usage is limited as well, because there can be biasness related concerns, and also we have this compliance hurdles that we need to take care of. So that's why this industry is uniquely complex, but it's also innovating with the new changes that are coming into this domain. Now, what you learned today from this session, I'll start by sharing some of the strategies and lessons that I have learned, things that work, that doesn't, and how you can apply these insights. And then I'll discuss some of the best practices to help build this scalable and secure solutions, which also meets the strict compliance requirements. And then we'll discuss some of the common pitfalls that most of the teams face, whether it's managing third-party dependencies or technical debts, or even like meeting this or handling this compliance regulations. And third, last, we'll discuss some of this actionable insights, things that you can take back to your team to accelerate your product development and launches as well. Now, as we move into this conversation, it's important to take a step back and look at the current state of health tech landscape. So in just the past decade, healthcare has moved from systems that were dominated by paper or isolated records to digital-first solutions like EHR. So this means all this transformation that's happening, it's happening inside a highly regulated and highly stakes environment. That means that the pace of change is really uneven. On one end, we have radiologists that are using this cutting-edge AI tools to help detect cancers. But on the other end, we still have fax machines that's used by various hospital administrations even today. So this difference between innovation and inertia is what actually defines these health tech landscapes. It's a space that's filled with friction, but has enormous opportunity for those who are ready to bridge these gaps. Yeah, as I just mentioned, the major transformation in healthcare that's happened is the shift from paper to AI. So not long ago, most hospitals and clinics used to store patients' records in file cabinets and used to use fax machines to share their patients' information with other clinics. But the shift to digital was a major transformation. So now we have electronic health record, which allows you to store data digitally. But if you really think about it, it did not really change the way care was delivered. At this point, it was more like taking notes on a computer instead of a paper. The real transformation actually began to happen when we started to use big data and predictive analytics. So now we had this data which was in digital format, easier to store and easier to access. So we could really derive insights out of it. For example, using predictive analytics, we could check which patients are at risk of missing out on their medication refills, or what conditions can get worsened if no action is taken on time. So predictive analytics has really helped move the healthcare from reactive, that is waiting for problems to occur and then take action, to proactive, that is take action beforehand before it gets serious. And we have AI-powered care that's really helping beyond data analytics. So in clinics or hospitals, it's helping doctors review this lab results and find out early signs of diseases. And but we cannot just treat it as a replacement. It needs to just give insights to the doctors to help make decisions faster. And then, while there are various challenges with this health tech industry, there are various opportunities as well. And some of the major innovations happen while working on these complexities. The first one is when different fields overlap. For example, the healthcare, artificial intelligence, and cloud native solutions. And we have often found when all these fields work together, we find solutions that wouldn't exist if they've stayed separate. And the next is patient engagement. Traditionally, this healthcare has been provider-driven. That is, the hospitals or the systems controlled most of the process, and patients were really passive. But now, the shift to digital is changing that. We have smartwatches, continuous glucose monitors, all such devices that's really helping patients take active control on their health. And this change is really necessary as well, because when patients get engaged, outcomes improve and costs often go down. And then in healthcare, AI is again available, but it cannot just be a black box. It really needs to provide meaningful value into the existing clinical workflows that are present. The best way to use AI in healthcare is not to replace the humans, but to provide various insights and documents that help decisions for providers to become faster. And if used in the right way, they become enabler that is helping providers and patients take better actions, and they become more of an innovation rather than just a piece of technology. And now, while we have discussed all of this amazing transformation, it's really easy to get lost in the tech itself. But among all this amazing transformation and changes, there is one thing that's constant and must always remain our focus, and that's the patient. So in healthcare, patient are our North Stars. That means whenever we design or build the systems, we don't just look at if it needs to be the fastest or cheapest. We need to make sure that it's really improving customers' life and providing better health outcomes. That means for every single decision we make in our system design, we need to keep patient as the form factor to make sure it really makes a difference in their life. And this we apply to every single system we build in healthcare, whether it's this complex infrastructure running in the background or it's a app that the user interacts with. Everything interface with their experiences. And that's why things like accessibility and trust are not just good to have features, they're really critical in healthcare. For example, consider a simple example, a checkout process. If the checkout process is really clunky, the customers can get lost and really impact them getting their medications delivered on time. And next, when we measure this measure success metrics in healthcare, we can't just rely on business metrics like system uptime or cost savings. These are just part of the story. The real thing that we need to consider are patients really improving their life with the technology that we are building? Is it really impacting the way the medication alerts are being sent to them? So when we keep patients as our North Star, we often find that our systems that we are building have real and positive impact on their health. Okay, so now that we have seen this digital transformation really transforming the healthcare industry, it often comes with various challenges that we must address. So in this section, we'll discuss some of those challenges in detail. The first one is navigating through maze of regulations. So security and privacy are really fundamental part of any software application in healthcare industry. So United States, you must have heard HIPAA, which is our main rule book that protects the patient's privacy and security of a patient's health and their data. And when we move to Europe, things are even more strict. They have GDPR, which is General Data Protection Regulation, that not only protects patients' data, but also their personal data. And we also have protected health information that we must always protect. And these are basically any data that can identify a patient. And these regulations are not fixed. That is, they keep changing. So we are not just dealing with old regulations. New ones can get added all the time. So what is compliant today can never be compliant tomorrow. So therefore, when we build our systems, we need to incorporate these regulation changes that can happen over time. And because we discussed the rules are strict and they change, so we cannot treat compliance as an afterthought. Therefore, we must follow what's called as privacy by design features. That means security and privacy becomes really fundamental part of the system right from the very beginning. And then we discuss about all these things, but we also need to handle state-by-state related regulations and laws. So this becomes a major challenge for developers and legal teams that have to battle through them every single day. And next, in healthcare, we cannot really afford the systems to fail. So as the user base increases, as your product grows, your system needs to able to handle that growth gracefully. And that means your system should handle this sudden spikes in your systems. For example, let's take a flu outbreak. During that time, millions of users could hit your system at once, requesting to book appointments during this critical time. But if your system isn't designed to scale, it's bound to fail and leaving patients without any access to care during this time. In contrast, a well-designed system will automatically add server powers during this time and gradually slow it down as the system improves. And the most important thing, if we want to help patients around the world, we need to design for that from day one. A global system not only handles it's not only something that converts text into different languages, it needs to solve much more than that. For example, a global system should handle different time zones so that the appointment times for the patients are the same, irrespective of the state they live in or the time zone they're present in. And it should also handle integrations with different countries' healthcare systems or handle different currencies. A company, if it's trying to expand its operations into different countries, will find that their software will not work if they do not handle all these things right from the beginning. And then they'll have to again go back to the drawing boards to fix it. How do we avoid these things in that case? So we as engineers do something called as load testing and performance monitoring, where we use we hit the system with hundreds of thousands of users at the same time and see how our system works under this pressure. And based on the weaknesses or bottlenecks that we find, we fix them so that when real world incidents happens, we are prepared for it. For performance monitoring, we build dashboards that check real-time checks of our system's health, thereby allowing users to take appropriate actions before they become system-wide issues. The next challenge is security and compliance. So, as we know, we deal with very sensitive patient information. Therefore, any breach can not only mean losing the data, but it can hurt a company's reputation and, most importantly, impact patients' trust and safety. So that's why, think about it, like patient data is really sensitive. So any breach can really impact the software company's reputation. And in the past, we have seen various health insurance related breaches that have occurred, which have impacted thousands and millions of customers and which led to loss of customer confidence. And in healthcare, patients really trust us with their data. And once that trust is gone, it's really difficult to get it back. And the major challenge, again, in the compliance is finding the right balance between making the product easier for users to use, at the same time ensuring it has various security protocols. For example, let's say a user is trying to log into the health app. We want to make it easier for them to log in without really adding more and more steps frustrating the users, while at the same time ensuring that no hackers can get into the system and steal the data. A good example of this for systems that handle it would be two-factor authentication, where we don't really frustrate the user with more steps, but at the same time ensure their security is protected. And we in health tech also follow what's called as zero trust architecture principles. That is, we don't really trust anyone or anything that's entering in our systems, even if they are in our own network. For example, if a developer needs to access AWS CloudWatch logs or gain access to a database to debug or diagnose an issue, we don't just grant them access because they're an employee. We verify each and every request that's coming into our system. So therefore, this really helps us protect any hackers from getting around in our systems by moving around and causing data breaches. And the last challenge is avoiding the trap of technical debt. We discussed in our previous sessions as well with various examples. I'll dive a little more into it. So technical debt basically happens when we take small shortcuts to get a product out faster. But the shortcuts really help, cause problems in the long run when we want to improve our code. So to compare, think of technical debt as a small loan that you take with higher interest. In short, it can help you get the feature out the door, but it really costs you more resources and extra time to fix the gaps and improve your code. And that's why things like governance review, architectural reviews are something that we need to do in order to avoid this situation. These are just small checks in our systems where our principal engineers or like senior engineers in the team review our design before we actually start building on them. It helps us identify if the system is ready to scale, it's built to last, and we won't run into the problems of really remodifying it again and again. And that's why we invest in maintainability earlier. So while it might seem like a lot of work in the beginning, it prevents mountains of problems later. That's about challenges. Now that we've discussed about this, let's see what an ideal scalable architecture in health tech looks like. So in short, the scalable architecture is something that is secure, flexible, that not only grows with patient needs, but also with the evolution of technology. So let's look at the health tech software development lifecycle. I would like to divide this into 4 parts. That's plan, build, validate, and release. To summarize the planning stage, this is where everything starts. We define the requirements and scope. What does the application need to do? We work with UX engineers, product managers to really identify the requirements and how the mock should look like. And then we classify this data, whether we are dealing with restricted data, highly confidential, or they can be like public. And this classification is necessary because it dictates the security controls that we will require later. And we do what is called as threat modeling. This is some checks that we put in our system to identify risk earlier. We work with security engineers to see what could go wrong with the system, where could data leak. And once we have done with all this planning stage, we build with compliance in mind. That is, we identify clear PHI handling patterns, that is ensuring that the data is restricted and access is also restricted as well. And even the smallest development practices change when it comes with health tech. That is, we cannot log all the details related to patient because of security and privacy concerns. Even if we log any identifiers, they need to be tokenized or encrypted. And while speed is really everything in software industry, even in health tech, the speed matters, but so does security. That's why in our pipelines, we build those security gates in place so that every feature or even bug fixes that goes to production, they pass those compliance check and ensure security is prevalent. And once we have made the code change, it's the step to check if our service is secure and built to last. So as part of this step, we do security reviews where the health sec engineers or privacy reviews our architecture, do manual code reviews, do pen testing to find issues before attackers do, and really go through the architecture in detail to see we aren't like really leaking any patient data. And once we identify these gaps from the testing, we fix them with priority and then test our features with small set of users, what we call as like user acceptance testing, to really make sure that our system works for our end users. The end users in health tech is basically patients, providers, insurers, and etc. And the next stage is once we have achieved all the steps, we decide on the go live strategy. That is, it's mostly via pilot programs with gradual dial-ups to ensure that we don't really cause any issues to large number of customers at once. For this, we build various dashboards, metrics, alarms in place that gives us real-time check of how things are holding in place once we have gradually hit the dial-up phase. And things never stop. With every audit that we do and with every feedback that we get from end users and with every regulations that come in place, the software evolves and we keep growing. So we saw the software life cycle for health tech, but how do we really scale the systems? Because we are not just building the solutions for today. We are building for millions of patients, decades of use. So we need to design for this from day one. This means using modular architectures, that is ensuring different parts of the systems can grow independently. And this could also mean using elastic cloud infrastructures. That is, we discuss that your system should be able to scale. For example, when millions of users hit during like a flu outbreak, your system should handle that. And then we should also use strategies like data partitioning. So think about a system which uses millions of prescriptions. So as the data grows, the queries can go down. So with data parsing, it really helps us keep the system fast and also your querying speed as well. The next part is the debate, a hot debate in software industries, whether you should use monoliths or microservices. So monoliths are easier to start with, but difficult to scale, whereas microservices are easier to scale, but they have their own complex problems. In health tech, the solution is not one or the other. Sometimes a hybrid approach works best. One guiding principle that we use is to define system boundaries around these compliance zones. For example, we could keep the PHI in a tightly controlled systems, whereas less sensitive data like catalog details or your product details could stay in a much open service. And finally, we have data modeling. So we know that in health tech, data isn't constant. We have new medical treatments, new medical codes, new regulations, and we need to ensure that our data models really evolve and are scalable with these changes. That's why schema evolution best practices are really common in health tech industries. And also, we need to ensure that our data models need to be structured in a way that it supports this predictive analytics. Without that, we cannot really train our models or derive insights. And then we all follow what's called interoperability first approach. That is, if you see healthcare is an ecosystem, the patients, provider, insurance, they all share the data. So if your system cannot talk to each other or integrate, they're bound to fail in the long run. Thanks. Next, another aspect of this scalable health tech architecture is resilience by design. This, I would like to divide it into three principles. The first one's redundancy in critical systems. So here we basically not just rely on single service, server, or database. We always keep backups so that if the primary source fails, we ensure that the request can go to the backup and the functionality or the application stays up for our end users. And the next is chaos engineering principle. This might sound strange, but the idea is very simple. We intentionally try to cause failures in a system to see how does the system respond in real life when it happens. And this could mean by adding simulations or network delays in our systems or taking down one of the microservices during non-peak hours to see how the system works and if it's really routing those requests to the backup and working as intended. So, and the last one is proactive monitoring. So we just don't want to find problems as they occur. That's why we invest in something called proactive monitoring. The dashboards, alarms, metrics that track for latencies, failures, timeouts, all this help engineers to take action on them before it really impacts the patients. And we also build various mechanisms to catch them earlier with certain severities as well. Depending on that, the developer can really take immediate action or can take at its own pace. Sorry about that. Now let's move into a different segment, which is security first engineering. So in health tech, we discussed privacy and security are really critical. So any issues or any breach could really impact patients' trust and their safety. That's why we think we monitor security and deal with them right from the very beginning. We don't add it at the end of a project like that. So in order to do that, we build trust through our security. So patients really trust our systems with their data. So when they log into our systems, when they review their prescription details or play around with their order history or transfer prescriptions, they expect their data to be safe. And that's why we must always encrypt or tokenize their details. So when patients really see their prescription details are encrypted and access to the systems are restricted, they really feel confident using our systems. And we have things like transparency privacy practices such as clear consent forms, data usage policy, and easy to read privacy notices that reinforces this trust. And that's why at this point, security is not just a technical requirement in the health tech industry. They are like a brand advantage. The next thing we need to make sure about is encryption, access, and audit trails. So this doesn't just mean encrypting things that are moving across the network, but also things that we use for like storing the details. And we, for example, even while we encrypt that, we ensure that even if users try to access them, they will not be able to. And that's why we define something called as role-based IAM roles. We only grant us particular permissions for users who can like actually see these details. For example, a pharmacist can really see the prescription details of a user, whereas other staff members will not be able to do that. And for a good security-based system, we must always have immutable logs for audits. And these are really necessary for compliance and investigations. So if ever there is a need for knowing what happened in the system, who accessed it, and what actions were taken, we need to have this audit trails that gives exact timeline of all these details. And finally, we need to invest in proactive threat modeling. We discussed this in the health tech lifecycle that we invest in it right at the very beginning at the planning stage. So the main core functionality of this is to anticipate vulnerabilities before they become incidents. And we add security runbooks as part of this step as well, which has various mitigation steps for each of the issues that we encounter during this pen test and threat modeling. So engineers have like right course of actions to like mitigate the issue when they face them in production. Now, let's discuss about AI in health tech. So AI is one of the major transformation in entire software industry. In health tech, it can really make a major move as well. If used in the wrong way, it can impact patients' trust and safety. But if used in the right way, it can really change the way care is delivered to users. So let's see where AI can really provide value. So the AI cannot just be used for the sake of using. It really needs to solve a real-world problem. One way where we can use AI is in predictive care. So we talked about how healthcare is moving from reactive to proactive state. So AI could play a major role in like analyzing which patients are at risk of not taking their medications on time, or like missing their refill prescriptions, or things that could go wrong if actions aren't taken. So, and the other thing is in workflow automation. So we have seen most of the providers and clinics do a lot of admin-specific tasks, such as reading the forms, or like taking notes, doing some analysis on patients' record, things like that. So AI can really help automate some of this task, making it easier for providers to spend more time with the patients, and at the same time reducing burnout on them. And the other area where we have already seen AI really help is with fraud detection and claim processing. So from financial side, AI is helping check some abnormalities in claims, thereby reducing fraud and saving money for both patients and providers. And the most important thing is, how do we integrate it into clinical workflows? Because AI cannot just work in isolation. They need to integrate into the existing workflows like electronic health record, or what we say EHR. And the major thing is, they cannot just be a replacements for humans. We need to ensure they only do the job of like providing insights that helps make providers make decisions faster. So, and most importantly, like providers should always make the final call and not rely on AI. And we need to ensure that it also minimizes disruptions. For example, if we incorporate AI just for the sake of AI, it's not really going to help, because if it cannot really fit into the systems that the providers are using, and if it's forcing the providers or doctors to learn new workflows, they are not going to use it. And also, when it gives some of these insights to the doctors, it needs to really explain how and why it came up with such an insight. Without that trust, like it's just going to be a technology sitting there in the system without providers actually using it. Next, even the best of best AI solutions are not going to be used if they cannot be compliant. So we need to ensure that patients need to know how their data is used in these models and how their information is really protected. And we need to make sure when if the regulators or the partners really need to know how the data models are trained what data are used, and how insights are generated. We need to ensure that those AI-based systems should be able to provide that. And last, we know AI always drifts with like years. For example, it can start to show biasness over years and can show false positive specific results. So it's important to always train our AI models with the real-time data and continuously evolve on it. Now that we've talked about all of this amazing AI-based systems, what does the future of health tech looks like? And how do we really prepare for what's coming next? So yeah, let's see what the next wave in health tech looks like. So for me, I feel the next wave of health tech is going to be driven by three powerful forces, which is AI, Internet of Things, and personalized care. So AI with the use of IoT can help advance the reactive to proactive care. For example, we have this continuous glucose monitors like Dexcom and Libre3 that tracks your glucose level in real time. It could send the data to cloud, and AI models could really perform analysis on it and predict the next spike before it really occurs, thereby like really giving the alert to users in real time and ensuring they take actions beforehand. And the next is remote patient monitoring at scales. So we have this smartwatches that tracks your steps, oxygen level, heart rate, and you also have this CGMs that tracks your oxygen level. But what if we say we could use this data and like feed it directly into the hospitals or the provider system? This could mean that now your doctor could monitor hundreds of patients at a given day, and this reduces the burnout on them, reduces the line in physical clinics, and it's really important in rural areas where the access to care is limited. And the next is in predictive public health models. So AI can really use large amount of anonymized public data and forecast public health trends. For example, during a flu outbreak, it could predict it early hand, depending on the intake data on the hospitals, the search trends on web, or even pharmacy sales for particular medications. So used in this way, AI can really make changes to what's coming next for us. So yeah, this is a wrap. I hope this session really helped you understand the health tech and software development lifecycle and how we build systems with security and compliance in mind. Yeah, thank you so much for your time. Any questions?
Questions?
Thanks. You talked a lot about giving patients the ability to understand where their health data is going as it applies to artificial intelligence. With the broad swath of patients in the healthcare systems, and I'm assuming also that the models are hosted models and not like you have your own farms and training your own inference and all of that. How are you educating patients on where their data is going across the board, and how do they opt out of their health information being sent to the large models?
Yeah, I think that's a really good question. Talking about models, I would say we have this cutting-edge AI models that are inbuilt directly into your systems. And about the models in broader scope, for example, in cloud, the way that we're using it, we try to educate them through the emails, whereas we sent out consent forms, or like how we are using their data through data usage policies. So where we actually say how their information is used on and for what purposes, and what part of those information, example, if it's their prescription history, how we are exactly using that in our systems to provide better experience in health tech for them. So it's a mixture of both things through some emails or through some of their reminders that we send through them in emails for their upcoming, for example, about pharmacy. So when we send them a prescription delivery notification email, we also like add some of those details about the data usage policies, and that's how we train them on it. And also, I think this is just the beginning where AI is starting to be used in the health tech. as we evolve, there are going to be various mechanisms in place that's going to be there to educate users on how these data are going to be used.
Hey, a quick question on the zero trust aspect of it. So when developers are needing to troubleshoot and they need access to the data, how do you guarantee the zero trust in there and make sure that they're only accessing the data that they're supposed to access? Because at least a lot of examples I've seen where somebody needs to troubleshoot them, they get access to the database and then, maybe it's timed out or whatever, but it's really hard to keep that fine-grained and make sure they're only accessing the data that they should be. And in your case, feels like it's even more restrictive since it's dealing with healthcare data. So can you elaborate on that?
Yeah. So for those, we basically provide access through our AWS prod accounts. For example, if a developer needs access to review a specific logs in the system, we do two things. We could have like a two-person rule. For example, they cannot just hit the read access button and enter the system. One of the members from the team also need to approve the request. They review that everything that they need to diagnose for this particular time. And at the same time, we also have for critical operations, for example, if they need to make a change to, let's say, a database in production. So for those things, two-person review doesn't really hold good. We have something that we call as a process. I can say about Amazon, we have some process controls built in place where they need to really document the steps they're going to take, and it needs to get approvals from the leaderships that they are going to change things in production. This way, we ensure that it's not as straightforward as to just log into the AWS account console and make changes. There are mechanisms and gating things kept in mind. Another thing is to keep in mind is they cannot make these changes throughout the day. We also build gates in the pipelines or the AWS account that, for example, after business hour, if they want to make change, it automatically denies those requests unless it's coming from a very senior leadership in the team and it's impacting thousands of customers, and only then we make change. So it depends on use case by case, depending on what the actual problem is and how much impact we are dealing with. Those mechanisms are something that we really take to help them enter the system and do the research.
Awesome. All right. Thank you so much. Let's give it all up for Tushar.